I start, how many football fans in here? Okay, we've got a few. So since we're in Dallas, what do you call 50 guys watching the Super Bowl together?
Dallas Cowboys.
The Dallas Cowboys. Okay, had to have some fun. So I'm going to talk about beneficiating fly ash or CCRs into product that can be used to reduce cement in use in concrete. And so that's where it's gray to green. And we do that via an electrostatic process, so it's non-combustion, right? We're the only non-combustion technology out there to beneficiate fly ash into a supplemental cement replacement. I'm not going to spend time on that, just we'll all go through. So again, I work with ST Equipment and Technology. I'll talk more about them, but basically we have the technology that electrostatically processes fly ash into a cement replacement. We are the technology provider. We build a piece of equipment, but we also build satellite operations. And so we're the business development arm. We'll design, build, and Separation Technologies is an accounting result within the company. And Separation Technologies, really there's no delineation between the two companies. Separation Technologies runs our fly ash operations and markets and sells the fly ash we produce. We're all part of Titan America, which is the U.S. operations of Titan Cement Group out of Athens. Titan Cement Group is somewhere around 2.3 billion euros. Titan North America is a good chunk of that, about 1.5 million. And we're based ST Equipment and Technology, or STET is basically need a mass. Titan Cement, real quick, founded in 1902, 14 cement plants in 10 countries, 2 in the U.S., both on the East Coast, outside of Miami, and Roanoke, Virginia. So 2 still growing areas. They're actually well positioned to continue growth based on location. 54, the cement group overall, 5,400 plus employees. You can kind of see our values there and read through that. So Separation Technologies, again, this is a sales, marketing, operations arm of the business. 6 operations right now in the eastern U.S. and 1 in the Canadian Maritimes. We also import cement into Tampa, Norfolk, and Newark. And we have a strong network to supply our customers. So Separation Technology is primarily an eastern U.S. business. Titan America, because of the location of cement plants, is generally eastern U.S. The cement plants and ready mix and aggregates. But STET is a global business. So we have units running worldwide in multiple markets. So originally this was non-combustion carbon removal from fly ash. And I think you all know if you get the LOI low enough, below 6, it becomes an excellent replacement for cement, 1-to-1, up to about 20 to 40%. And given our aspirations to reduce CO2 and the cement business being a very big emitter of CO2, fly ash is one of the materials the cement industry looks at as part of their decarbonization plan. It's proven robust over 25 years, and we're operating in a harsh environment. So fly ash, minerals processing, and also it just so happens to separate fiber from protein in plant-based meals and flours. And if go to the grocery store, protein bars, everything is around protein. We happen to have a stake in that area as well. Over 25 million tons processed, 25 million tons of CO2 saved when you start looking at our fly ash business. So what else do we do? Well, I said we develop and manufacture Triboelectric electrostatic belt separators. talk more about that in a few minutes, and develop satellite operations for fly ash, minerals, talk about plant-based protein. It's really a solution, right? A solution, we design a solution around our separators, around our technology. So if it's harvested ash, right, we're going to also design a process around that, including drying and grinding, whereas if it was fresh ash, we would just have to separate it. We don't need to do those other steps. But we'll design the processes, including our technology, build satellite plants. They might be 100% funded by our company, or there might be a co-investment with the utility. So I'm not going to spend a lot of time talking about our technology itself. The bottom right is a picture of the separator. The schematic there, it is a belt-driven. You've got rollers and drives on two ends with tension control. The belt is a very narrow gap between the top and bottom of that belt. That belt's moving at about 45 miles per hour. And the retention time in that unit is less than a second. So kind of say in a split second, so it's kind of cool. It's almost as cool as nuclear fission. In a split second, we are making that separation. It just so happens that unlike materials, when they collide, similar to dragging your sneaker across the carpet, you will exchange electrons. And it just so happens that carbon in the fly ash will charge positively, other minerals charge negatively, and the carbon in each component is drawn to the opposite charge electrode. We don't charge the particles charge themselves by being dropped into this unit between a belt with a very narrow gap, causing millions of collisions very quickly, and those particles are charging and then separating. And that belt then is conveying the material to opposite ends depending on positive or negative charge. So again, I said the benefits are certainly based on CO2, the interest in reducing that, especially now with the focus being on trying to get to carbon neutral. Drying and processing fly ash from landfill, right, only reduces the CO2 savings by 10% relative to the CO2 saved by cement, replacing cement. And so from a sustainability standpoint, right, this is not only driven from the fact that you've got a waste material that has a value being used as a building material, but also a significant CO2 savings. And even taking it from an impound or a pond, you're talking about essentially still, virtually retaining the savings of, just cement replacement, even though you're doing some grinding and drying. So if you look at our technology versus combustion, and there are some other folks that will use combustion to burn off that carbon. Obviously, if we're trying to save CO2 emissions, you'd rather not use combustion, right? If you're talking about sustainability, you'd rather try to maximize your CO2 savings, and you do that through our process. Our process uses very little power, only a few kilowatts per ton of feed, and the yield tends to be 75 to 90%. The data here was taken from issue 2, 2023 Ash to Work. They were estimated from their chart. So they're not, this in particular is not our data, right? Verified by a third party. And if you look at here, the savings of roughly 815 kilograms of CO2 per ton versus if you were to process and use combustion, right? You get less than half of the savings retained. So from a standpoint of capital investment, from a standpoint of CO2 saved, right? This ends up being the process of choice. We can handle up to and even over 20% LOI fly ash, and produce a consistent product. We can target the LOI desired, whether it's 3%, whatever that is, depending on the market, and control it to a very consistent product, even with variable feed. We've done multiple on-site demonstrations. I think the whole subject or question around whether or not harvested fly ash can meet the same performance of fresh fly ash when used as a cement replacement, I think those questions have all been answered. We've done multiple demonstrations, Pennsylvania, Georgia, and the UK over the last few years, and consistently have demonstrated ability to handle up to and over 20% material with up to over 20% LOI with consistent results. This is a schematic. I'm not going to spend a lot of time on this. You see the names ProAsh and Ecotherm. So ProAsh those are our trademarks. ProAsh being the low LOI cement replacement, and Ecotherm, we're going to have a co-product. We don't produce any waste, and there's no destruction of mass, right, or creation of mass. So it's all based on mass balance, right? And in terms of the amount of ProAsh or the yield of ProAsh per ton of feed, Ecotherm just is the high carbon co-product that we produce, which if it was a ongoing coal-fired power plant, we could feed that back into the power plant as a fuel source. It can go into a cement kiln as a fuel source. Or it can go into some other materials that don't require the same quality of cement or concrete. This happens to be our so Bruner Island is a fresh ash operation, but we've also brought in drying and grinding to do demonstrations, and we've also brought in ash from other power plants to run through our process. We have commercial separators at this location, and we've taken from pond up through the process, have done all the testing and confirmed, right, we produce an equivalent product, but we also have a equivalent performance with our equipment. These are just some additional pictures. I won't spend too much time. I don't know where we are in time. Bottom right is our electrostatic separator. The left-hand side, and this is a Bruner Island still, is a dryer we brought in for the demonstration. Again, we're part of a cement company, so we do know how to test for strength and confirm that all the material we've produced there and at other demonstrations has met all the strength requirements. Some specific data, again, right, roughly equivalent to fresh ash produced. The second demonstration we just co-hosted with a company called the Tritter. They have grinding and drying technology in the UK, Coventry. We shipped our mobile separator. So we have a pilot scale separator that has the same length, electrode length, as our commercial scale. It's just 1/7 the width. So it scales up very well to commercial scale. In fact, we use our pilot separator to do all of our scale up financial calculations. All those scale very well to our full commercial scale separator. This commercial scale separator, by the way, will handle somewhere around 30 to 40 tons per hour. Our pilot would be roughly 1/7 of that. And we can ship that in a trailer. We have it all contained in a trailer, and actually shipped it over to the UK. We actually hosted over 50 stakeholders. We looked at material from 6 different locations within the UK and processed that. Highly variable, but again, we're able to produce a consistent LOI product. The picture on the right, the feed is the top left at 10 o'clock. You see the color difference, the Pro Ash, where you have carbon removal, you would expect to have a lighter color. And then Ecotherm, or the high carbon co-product, you obviously see the darker color there, the evidence of the separation. We also did a program down at Georgia Power at Plant Bowen with the EPRI. Now I forget what it stands for. Again, picture of our pilot separator in a trailer brought down to Georgia, and we were processing fly ash. Again, so another location. It was harvested ash. In this case, they were looking. It was a project to extract rare earth elements, and in their process, there was more effective. The effectiveness of the process was based on how much carbon was left in the material. So we were asked to remove the carbon for then continued processing to recover rare earth elements. So we're, especially through our owner and our sister company, right, we're able to handle from excavation right through to sales and marketing. Said Titan it has an aggregate business, right? Done it. We know how to excavate. We can do the whole thing, or we can do parts of it, and that really comes down to what the customer needs and what we're being asked to do. And just so in summary, our separation technology is most widely used in terms of fly ash reduction or carbon reduction in fly ash. So that said before, more than 25 million tons processed to date. Fly ash drying and sizing plus our separation has been demonstrated on numerous occasions, and with excellent performance on 2 different continents. Ponded ash performance in concrete is equivalent to fresh ash after STET processing. It would say ponded or landfilled. And I think the key thing to me, if we're all talking about right the goals to reduce CO2, is first sustainability. So from a capital standpoint, we tend to be much lower a capital investment compared to a combustion process, and obviously lower emissions, therefore increased CO2 savings compared to a combustion process. I've got this material, I don't want to add CO2 to the atmosphere, why combust it? And then we have proven technology to do that that can handle a wide range of LOI and a wide range of and variable feed and produce a consistent product. And from the business model, again, we can do the whole thing. We can do parts. We're willing to license and sell our technology or equipment. Again, we don't consider ourselves to be an equipment company because we do a lot more than just sell a black box. And thank you very much for your time, and any questions, please feel free to ask. Good, I thoroughly bored you.
What are the specs on your input on the civil contract?
All right, what? I'm sorry.
So you're going to need to have that some amount of pre-processing done before you receive the ash to run through your tight stuff. What is the spec?
Yeah, right. We're going to ask for you to screen quarter-inch screen, and we're typically 20 to 25%. And a lot of that depends on the deposit. Okay, and we can work around numbers, but generally we're looking to have the material screened through quarter-inch, and somewhere to 20 to 25% moisture. And depending on the situation, the design would be based on what the capabilities are. Thanks for your time. Appreciate it.